Hello friends, this is Gunja Vijayashree, working as an assistant professor at Department of Physics, JMD College, Sinnar. This is our first lecture for TYBSc Physics, paper 3rd, which is titled as Classical Mechanics. In this lecture, we will first see introduction to classical mechanics, that is, we will discuss what is classical mechanics, and then we will start our first chapter in which we will discuss our first topic, that is Newton's laws of motion. Let's start with the introduction to classical mechanics. Now you all will have a question that what is exactly classical mechanics? So mechanics is nothing but it's all about describing the motion of macroscopic solids and fluids under the influence of forces. This means what? Any object, macroscopic object, that should be macroscopic object. Now from your previous study, it is clear to you that what is difference between macroscopic objects and microscopic objects. Okay. So whichever object which is macroscopic in nature and which is under the motion, then study of such objects under the influence of forces, means what will happen when the force is applied to such a moving macroscopic object, that study is nothing but classical mechanics. There are few examples of classical mechanics. If one study planets moving around the sun, then see in that picture, sun is at the center and planets are moving around the sun. So motion of this planet around the sun and its study under the influence of forces, which forces are acting on such planets which are moving around the sun, that study is nothing but classical mechanics. Another example is apple fall on a human head, that is apple is in motion and study of that motion of apple under the influence of gravitational field, that is one type of force. Such study is known as classical mechanics. So this is all about introduction to classical mechanics. This was first introduced by Copernicus, and after Copernicus, scientists Galileo Galilei as well as Isaac Newton both invented and elaborate this concept of classical mechanics. Now this was introductory part to our subject, that is classical mechanics. Now we are going to move towards our first chapter, that is mechanics of system of particles. Now it's clear to you that what is mechanics. So let's see contents of this chapter. So very first there is introduction to mechanics or introduction to this chapter. So introduction is nothing but study of mechanics, that we have already seen. Then second point is Newton's laws of motion. Then applications of Newton's law, and which applications we are going to study, that there are three types of applications, that is motion of a charged particle in constant electric field. Then second, motion of charged particle in constant magnetic field, and third is motion of charged particle in cross electromagnetic field. So these three applications that we are going to study in this chapter. Okay. Then after these applications we are going to see system of particles. In previous application we are going to study the single particle system, and after that we will study the system of number of particles, that is more than one particle. Okay. And at the last of this chapter we will discuss all the problems based on this whole syllabus. Okay. Whole contents. Then let's move towards the first point, that is introduction. So in introduction, let's discuss first about mechanics. So we have already discussed that mechanics is nothing but study of motion of material bodies or moving bodies, and this study is under the influence of forces. Okay. And this mechanics is further divided into two branches, that is first is kinematics and second branch of mechanics is dynamics.
So these are two branches of mechanics. In kinematics, what do we study? So in kinematics, motion of bodies is described in terms of displacement, acceleration, velocity, mass, force, etc. That means what? In kinematics, we will get geometrical description of motion of a body or a object. Okay, so kinematics gives us the geometrical description of motion of any object or a body, while dynamics gives us the motion of a body and its causes producing their motion is studied under the dynamics. In dynamics, we study laws of motion of body and causes which produce that motion in the body. These causes are studied in dynamics. So basically dynamics gives us causes of motion, that means why objects are moving, that reason behind the motion of object is given in the branch of mechanics which is named as dynamics. Okay, and first branch, that is kinematics, which gives us just a geometrical description of a motion of a body. So now particle dynamics can be developed with force, mass along with the displacement, velocity and acceleration, while principles of dynamics are explained on the basis of Newton's laws of motion. That means if we have to study dynamics, we will need to study Newton's laws of motion. And what is dynamics? Dynamics gives us the causes of motion, the reason behind the motion. So if you have to study reason behind the motion of a body, why body is moving, then you have to study Newton's laws of motion. So let's see what are Newton's laws of motion. So Newton's laws are not output of any mathematical derivation. Newton's laws are not derived by using mathematics. These are just output and observation of experiments done by physicists over the objects which are in the motion. That means Newton's laws of motion cannot be proved. Okay, there is no proof or no derivation that from that Newton's laws are derived, but these are just observations done by scientists, physicists on the objects which are in motion. There are some experiments done by scientists and these experiments gives us some conclusion, that is nothing but Newton's laws of motion. So Newton's laws are the fundamental laws. What do you mean by fundamental? Fundamental means these cannot be deduced or proved from any other principle. That means Newton's laws are not based on other principles. These are fundamental laws. That's why Newton's laws are also called as empirical laws. Okay. So first move towards Newton's first law of motion. Let's discuss about the Newton's first law of motion. So before going to statement of Newton's first law, we will see two examples in which Newton's first law is applicable. So our first example is passenger traveling in a bus. Suppose this experience is taken by all of you, that you all have done traveling through bus. So if you are traveling by standing, you didn't got any seat and you are standing in the bus and bus is moving. So if you are traveling in a bus and bus is moving with a uniform motion, that is constant speed of bus is constant, and then you are moving in the you are traveling in that bus by standing. You have hold some hanger and you have hold yourself in the bus. Why did you hold that hanger? What is reason behind this? Because if at the moment, at the time of instant, driver apply a brake to bus, what will happen? What will happen to you? You will get fall down on the floor. Why? Because you are in the motion. You are in the uniform motion with constant speed, and the tendency of your body is that your tendency is to continue that motion till and until your motion will be continue up to what? Up to any force is not applied to you. In this case, if driver is applying brake, then force is applied on the tires and bus is stopped suddenly. So there is force acting on you. So because of this force, your state of motion, your motion state is changed, and due to which you will fall down. That is, here Newton's first law is applicable. We will see statement, then you will get idea that how Newton's law is applicable in this case. Then second example is tug of war. In your childhood, everyone had played this game, tug of war. So in tug of war, you can see here there is a one center, and then there are two teams in opposite direction. They are pulling the rope towards their self. So if suppose this is our team 1, let's say this is our team 1 which is on left side, and team 2 is on right side. Then both teams are pulling the rope towards them. Then what will happen if the force applied by team 1 to the rope is less and force applied by team 2 is more? Then team 1 participant will pull towards the team 2, and team 2 is winner. If this force is very much large, then these participants or competitors, these will get fall down on the floor. So you can see here how they are applying force. So these are few examples in which Newton's first law is applicable. Now let's see what is statement, then you will get idea that how Newton's first law is applicable in above two examples. So statement of Newton's first law is every body continues its state of rest or a uniform motion in a straight line unless it is acted upon by external unbalanced force on it. What this means? This means that every body has tendency to continue its state of rest or uniform motion. Now see, uniform motion, this will be applicable in our first example, that is passenger traveling in a bus. Your state is what? State of uniform motion. You are moving with a constant speed and along the straight line. Then you will continue that motion till and until driver didn't apply any brake. Okay, if driver applies brake, then body will change its uniform motion and it will get suddenly stop. Why? Because there is an external unbalanced force acting on that body. So this is statement that every body continue its state of rest or uniform motion in a straight line unless it is acted upon by external unbalanced force. There is also one example in your day-to-day life, that is everyone have seen fan. Okay, so fan is ceiling fan or any table fan, any type of fan. If you put it on, okay, fan will start to move in a circular motion. Okay, then after that, after some time, if you put off the fan, what will happen? Did fan get suddenly stopped? Even though power is cut off, exactly at that time of instant, fan didn't get stopped. Why? Because fan having tendency to continue its uniform motion, but you have applied external unbalanced force, you have put off the power, and due to power cut off, fan will get stopped, but it will don't get stopped suddenly, it will continue its motion for few seconds, and after that it will slowly get stopped. That is nothing but our Newton's first law. So let's see what are unbalanced force. These are oppositely exerted forces, and equal means these are same type of forces but just in opposite direction. Okay, then there is one concept, that is concept of inertia. What is concept of inertia? It is tendency of a body to remain in a state of rest or uniform motion. Means every body will have the tendency to remain in a state. If it is in rest, that body will remain in rest, or if a body is in uniform motion, that body will continue its motion till and until external force is not applied on that body. So that tendency of a body to remain in its state is known as inertia. Now there are three types of inertia: inertia of rest, inertia of motion, and inertia of direction. So what is inertia of rest? Inertia of rest means tendency of a body to remain in a state of rest. If you have keep any object at the rest, it will stay in a rest up to what extent? Till you are not applying any external force to change the position of that object will remain in a rest. So this tendency of that object is known as inertia of rest. Then another is inertia of motion. Okay, if any body is moving with a uniform motion along a straight line, then if you are not applying any external force, unbalanced force, then that body will not change its uniform motion. It will remain in its motion itself. If you have to change the direction of that body or you have to stop that body, you will need some external force, and then only that body will get stopped. For example, if you have to stop the bus, you have to apply brake. So this is nothing but inertia of motion. And last is inertia of direction. If a body is moving in a particular direction and if you have to need to change the direction of that body, for example, bus is moving along a straight line and suddenly there is a turn on the road. So what will happen? You have to turn the bus. So to turn the bus, you will need external unbalanced force. So this tendency is known as inertia of direction. Okay. So what we study in Newton's law? In Newton's first law, there is study of an object which is in a motion when there is no force acting on the object. That means also we will need to study net force acting on a matter. If net force acting on a matter is 0, that is vector sum of all the forces acting on the object is 0, then Newton's first law is applicable. That means in Newton's first law, net force is very important. Okay, and Newton's first law tells us about the motion of a body when there is no force acting on the object. That means it will tell us that what will happen to motion of a body when there is absence of force, there is no force acting on a body, and it will not tell us about the motion of a body when force is applied. Okay. So there in previous slides you have seen the concept of net force. So to study net force, to get idea that what is exactly net force, let's discuss some examples. Okay. So force is a vector quantity. So what do you mean by vector? Vector means force will have direction as well as magnitude. So now see, suppose you are having an object with mass small m, okay, and if that object is in rest, okay, now I want to move this object, then what do I need? I will need some force. Okay, so now suppose I want to move this object from my left to right direction, from this direction. Okay, I want to pull this object from left to right. This means object is over here and I want to change its position to here. Okay, so what do I need? I will need some force. So let's apply some force. That force I am going to call as F1 bar. Bar is given because force is a vector quantity, and see, this is the direction of the force that we are applying, that is direction of F1, which is from left to right because I want to pull the object from left to right, and 1 Newton gives us, that is magnitude. This is amount of force. This much amount of force we are going to apply to this object. That means I will apply 1 Newton force in direction left to right to pull the object. Now here, do any other force is present? No. Except F1, there is no other forces acting on this object. So what will be net force? What do you mean by net force now? Net force means vector addition of the all forces acting on that object. Now here only one force is acting on this object. That means our net force is nothing but F1. This is our net force acting on this object. Now here, do our net force is 0? No. Here net force is not equal to 0. That means this is unbalanced force. I am telling you that what do you mean by unbalanced force? Unbalanced force means when the net forces, that is net total vector sum of all the forces is 0, that then forces are balanced. Okay, in this case net force, that is total force, vector sum of all the forces is not equal to 0. That means this is unbalanced force. Now this unbalanced force is applied to a object which having mass m is at rest position. So what will happen? Let's see. Now observe this figure, the second figure. There is animation, you have to observe it carefully. Look at this. By application of force, what do happen? Your object started to move. This is nothing but Newton's first law. Okay. See, object continue its state of rest. Up to which extent? Till you didn't apply this much force. Okay. F1 is not applied to object. Object is at rest. The time when I apply force, then object started to move. Now motion of object was from left to right. Let's see another case. So see here, net force is not equal to 0. So these forces are unbalanced force. When forces are unbalanced, then object will change its state of rest or uniform motion.
Now let's move towards the second example. Here I am taking same object with mass small m, and now in this case we will apply force from our right to left. This means I am pulling object towards the left. In previous case we have pulled the object towards our right side, that is we have applied force from left to right, which was F1 equals to 1 Newton. Now in this case we will apply force from right to left, that is I will pull the object towards the left, and I am going to apply force F2 bar, which is equal to minus 1 Newton in this case, because in previous case the force in right hand direction we have taken as positive, and by convention the force opposite to F1 is F2, that's why it will be with negative sign. That's why we are taking here F2 bar as a minus 1 Newton. Now let's see what will happen when I apply force F2 bar equals to minus 1 Newton in left direction to my object with mass m. Let's see. Observe the animation. See, now I have applied force F2 bar. Let's see what happens with object. See, object move towards the left. This means what? Due to unbalanced force, object has changed its state of rest. Initially, object was at rest, and after that, when I applied F2 bar as minus 1 Newton, then object start to move towards the left. Here, the total force, that is net force, is how much now? It is not equal to 0. This means what? This is unbalanced force. How to calculate net force? We have already discussed. Net force is nothing but vector sum of all the forces which are acting on this object with mass m. Now here only one force is acting on object, that is F2 bar. That's why net force is not equal to 0. This means these are unbalanced forces, and according to Newton's law, if we apply external unbalanced force to our object which is in state of rest or uniform motion, then object will change its position. So this is Newton's first law. Now let's move towards the third case. In this case again I am taking same object with mass m, but here we will apply two forces to this object. In previous two cases, that is case 1 and case 2, we have applied force towards the right and towards the left simultaneously, and due to this force object has changed its position towards right and left simultaneously, right? So now in this case we will apply force at a time, at the same time when I am going to apply the force F1 towards the right direction. At the same time, I am going to apply force F2 towards the left direction, and we will observe what will happen to the object. So let's see. By application of force which is equal and opposite in direction, there is no change in a object. Now why this is happening? Let's observe this. Here see the net force which is F bar, which is equal to 0. How we have calculated F bar? F bar is net force, that is vector sum of all the forces acting on this object M. In this case there are two forces, F1 bar and F2 bar. Now net force, that is F bar, equals to F1 bar plus F2 bar. So addition of 1 Newton with minus 1 Newton will be equal to 0. And if net force is 0, this means that force is balanced force, and since force is balanced, there is mutual cancellation of these forces, effect of these forces with each other. This means effect of this force is cancelled by F2. That means whenever I apply F1, whatever effect is there on the object, that effect is neutralized by the force F2, which is minus 1 Newton, because these are exactly opposite forces. That means forces are balanced and object will not change its position. So this was all about the Newton's first law and the end of this first lecture, introductory lecture, and we have started our first chapter. Now in next lecture we will discuss about Newton's second and third law with examples in detail. Thank you.